Right. So this is another important question, although this is theory. Okay. So an organic compound A contains 39.7 of carbon. So this is the normal way that we do. So we write carbon, hydrogen, oxygen, and we write this as 39.97, and this is 6.73, and oxygen is 53.3, right? So this is the normal way that we used to get. Then we divide this by the molecular weight, 12, 1, and oxygen is 16. So you will have some value. Then we divide it by the smallest one to get the stoichiometric ratio of the organic compound that is given in the question. Okay. So when you do this calculation, you will see your answer is 5. This will be CH2O, which is our empirical formula. Don't forget, they are asking about the empirical formula. So what is this compound? This compound is, it should be formaldehyde, right? Right. So in a similar way, okay, the important thing is coming now. So let's say we are finding the empirical formula of a compound, and they are asking about the formula. For an example, let's say molecular formula of a compound where they have carbon, hydrogen, let's say not hydrogen, we will have chlorine for an example. There is a compound which contains carbon and chlorine, right? You know what are the compounds that have carbon and chlorine. So carbon and chlorine is CCl4, and that is the common one. And they have found the stoichiometric ratio of carbon to chlorine is 1:3. Okay. Can you just predict the molecular formula of this one? Because this question is very straightforward. You have to just put the values and divide it by the lowest number that you get to get the empirical formula. Okay. So here, let's say you do this calculation and you do the division and everything, and finally you get organic compound which contains carbon and chlorine. The ratio is 1:3. So can you like think about the formula, molecular formula for this particular question? Okay, so this was earlier, we discussed this one where we had KSP and all those things, and we do the sum and everything here. I hope you saw this one, right? Because there is KSP, there is this equilibrium we write, then we have the final equation here, and we will write K1 and K2 as this, and when we do the calculation, so you will have this nice calculation. So instead of S2 minus here, we put KSP over Mn2 plus. So we will have K1 and K2, which is equal to KSP times H plus squared over Mn2 plus into H2S, which is 1 over Kc here. So we put here, so we Kc is finally equal to KSP over K1 into K2. So KSP, you have the K1 and K2 ratio. This will be around 10 to the power minus 20. This is 10 to the power minus 15, minus 5. Then there is this cut where we do 10 to the power minus 15 or 10 to the power minus 20. You will have 10 to the power 5. Okay. Now I was talking about this question. So when you put these values and when you do the ratio and when you take this, so you will have this empirical formula. So this question is straightforward. Now what I am asking here is, when you have all these calculations done and you have a ratio of chlorine to carbon is 1:3 in a compound, can you suggest a molecular formula for this one? The stoichiometry in the compound is carbon to chlorine is 1:3. I am asking, can you think about a formula for this compound? I am not asking either empirical formula or molecular formula. Just can you guess a formula for this one? So if you can think, so what is your answer? So I have one answer. Yes, you can think. So what is your answer? What is it? CCl3, CCl4. What is it? Because I have given the stoichiometry between carbon and chlorine. So what should be the formula for this one? Because this question is easy, because just you have to get the stoichiometry and you add it and that's it. Now here I am giving an additional option for you. After I find that carbon to chlorine is 1:3, can you suggest me an answer for this one? No, no idea. Okay, so I will go through this. So the idea is, okay, so if you have this 1:3, the formula of this one should be CCl3, right? That is the formula. But the problem here is when you think about the structure of this one. So there should be a carbon like this, there should be chlorine, there should be chlorine, and there should be a chlorine. But carbon in the valence shell, there is another electron that is present. Okay. So according to this stoichiometry, the formula, if you think it is CCl3, this will become ending a radical. This is not a complete molecule. Okay, so this is a radical. So this is problem because you don't have radicals. So what we'll do here, when there are this type of radical, two of them will combine. So eventually the formula of this compound, the accepted formula will be C2Cl6, because there will be another radical that is coming up and forming the bond with this single electron of it, and this will form this type of a compound. So this will be C2Cl6. Okay, this is one of the old questions that have been asked many years ago, like in for an example, this could be in 1990 something, this question that I explained to you here. Because the question was asked in a similar way, but when you calculate this formula, it shows the ratio is 1:3, but they have asked a acceptable formula. So if you think this is 1:3, you can just give the answer CCl3, but it is wrong because CCl3 is a radical, it cannot exist. So you have to give its dimer, which is C2Cl6. Okay. So did you understand this one, the example? So did you understand the example that I explained here? You all are here, right? Okay, so that's good. So if you understand this example, that is also good.